GMAT all day.
Typically in math, especially math tests, we are taught to solve for things. We are taught to solve for X. So one way, therefore, that the GMAT tries to confuse and mess with people is they ask you to not solve for things. So what do I mean by that? They give you data sufficiency questions, for example, where you don't need to solve for X. You just need to know if you can solve for X. Another thing that they do is they ask these could be true questions. And so this is why I say that GMAT is not really a math test. It is more of a logic test because you have to unlearn a lot of the stuff that you were taught in math class and then relearn it in a slightly different way. So with these could be true questions, think about what they're saying. If they're asking you what could be true about X, it probably means that there is not a single value for X. There are multiple, if not infinite, values for X. And so you just need to determine what is true about all of those values, all those possible values for X, so that you know from a list of values what could be the value for X. And so in this case, why do they like to incorporate these could be true questions with divisibility? If you think about it, when we're talking about the number of factors that a number has or the number of multiples that a number can have, well, there are many possible multiples and many possible factors, and therefore they like to ask them in these could be true questions. So this question says, if m and n are integers such that m over n is equal to 0.164, which of the following could be the value of m? So the reason these could be true questions throw people off sometimes is because even if people pick up on the fact that they're probably not going to be able to solve for m in this case, they don't know. They sort of ask themselves, well, how far am I supposed to go? How close should I get to solving for m before I stop, knowing that I probably will not be able to solve for a single value? I say just go as far as you can go until you can determine something about m. And the more specific piece of information, the more specific property that you can determine about m increases the probability that only one of your answer choices will fit that pattern. So I want to figure out what could be the value of m. I just want to figure out anything about m to start. And so the first thing I got to do is I got to write this out vertically because I hate it when they give me horizontal fractions. Now, in this case, I wrote this question, but I think I wrote it like this because the GMAT likes to write fractions like that. So m over n is equal to 0.164. Another thing I prefer is I almost always, when I'm given decimals and I'm doing arithmetic, I prefer to convert them to fractions because fractions usually really just are integers. You just happen to have a top integer and a bottom integer. So 0.164, I can start by saying that's 164 over 1,000, and I can simplify that. So m over n is equal to, so these should each be divisible by 4 because 64 is divisible by 4. So 1,000 divided by 4 is 250. What's 164 divided by 4? 41. So m over n is equal to 41 over 250. Now they're asking me about m, what could be true about m, so I should probably get this in terms of m, multiply each side by n, and I get m is equal to 41 over 250 times n. So this, I would say, is about as far as I can go. I cannot simplify this fraction anymore. I have it in terms of m, which is what they're asking about. So now I sort of have to take a step back and say, so what is this telling me? This is also a case where I'm telling you, do not gloss over the fact that they tell you m and n must be integers. That is very important to questions like these. Because think about what that means. If they didn't tell you this, well, m and n could be anything, and now there are infinite possible values for both m and n. But if they must be integers, well, now we have, I don't know what you call it, less infinite possibilities. We're more restricted what m and n could be, because n over here has to be an integer, but n also has to give you an integer for m. So what does that mean? That means this n here must cancel out this 250, because we just sort of rearrange this. We can think of this as 41 over 250 times n. That's the same thing as 41 times n over 250. And so the only way to get an integer on our left side is if we cancel out this denominator here, this 250. The only thing that can do that is our n. So if we want to infer everything this expression is telling us, given that m and n must be integers, well, starting with n has to be a multiple of 250. So they just as easily could have asked you what could be the value of n, and all of your choices would have to be multiples of 250. or to say the correct answer choice would have to be a multiple of 250. Now, what about m? So just because n must be a multiple of 250, that does not mean m has to be a multiple of 250, because not all of that 250 gets included in the m. Part of it is just being used to cancel out the 250 on the bottom here. So for example, if n is equal to, let's say we got n, and then we got a value for n over 250. So if n is equal to 250, n over 250 is 1, n is 500, n over 250 is 2, if n is 750, n over 250 is 3. So n over 250 could just be sort of any integer. So really we can think of m is just equal to 41 times some integer. So if we want to know what is this telling about m, this is really just saying m has to be a multiple of 41. That's really all you know. Unfortunately, there is no divisibility rule for 41, but I don't think I need one here, because answer choice E is the obvious multiple of 41. Now, it is true that I don't necessarily know that these guys are not multiples of 41, but there can only be one answer choice. So as long as I did not make a math mistake, E has to be the answer. And you can go and test for yourself to verify that none of these are multiples of 41, which I hope is the case, because I'm the one that chose those numbers, but they shouldn't be. So the answer is E.